All right, everybody. Welcome to another OpenShift Commons briefing. As we're wont to do on Mondays, we're going to have an Ask Me Anything question with one of the projects or offerings or feature sets for any of things in the OpenShift ecosystem. And today we have the team behind Red Hat's Advanced Cluster Management for Kubernetes. That's a mouthful, but Scott Berens is going to kick us off and introduce all the folks that are here today to answer your questions and tell you a little bit up front about what that all means. And I'll let Scott take it away. And you can ask your questions in the chat wherever you are on the live streams or if you're in Blue Jeans, and we will try and answer them today. So Scott, take it away.
Thanks, Diane. Thank you so much for inviting us into the Commons briefing. Big fan of your work. Very excited to see you last year on the boat. I know other folks were out there in California at KubeCon. Those were the days when we could get together. But alas, here we are at a virtual Ask Me Anything. I'm here. I'm a product manager. I'm Scott Berens, work with Rackham. We affectionately refer to that long string of text as Rackham, Red Hat Advanced Cluster Management for Kubernetes. And I'm joined by some esteemed colleagues. I'll do a quick intro for them. So our senior architect, Michael Elder, who's been in this multi-cloud, multi-cluster space for at least 2 years, if not more. Josh Packer, his sidekick, the Robin to Batman scenario, does well here for us. Josh really focuses as an architect in our application management space, a lot of the advanced scenarios around GitOps, ensuring that we can place workloads across clusters and clouds. And our esteemed technical marketing manager, Jimmy Alvarez, who is located in sunny Florida and wishing he was outside on the beach right now. So I appreciate our panelists for being here. I'm fired up. I'm excited to be in front of this audience. It's been a long time in coming, but really, multi-cluster management has value to the world, and we hope to bring it to you. We hope you're already aware of the fact that we GA'd in July. We have a 2.0 release that came out in July. Of course, our announcement goes back to Summit, and we'll be quickly accelerating to a 2.1 release coming out in the fall. So we're working hard for you today. I hope we can answer some of your questions. We really don't want to spend a lot of time on slides, but I'm going to literally just race through for like 2 minutes just to kind of set the table for where we're at. We're in this space of multi-cluster management. I think the fact that our product title includes the word Kubernetes should really clue you in that we're really focusing on the Kubernetes plane here. We really want to normalize that experience across, from single cluster to multi and beyond. So distributed, looking at hundreds and thousands of clusters that you're managing in your fleet. We all get it. Like Kubernetes is the decision. It's the market trend. This is where we're going. And so again, what we're trying to do is bring that capability into a central management plane, into one single hub that can start to manage the fleet. And whether you're a developer or wherever you're at on this kind of train, if you're in the DevOps cycle and you're really starting to get into the operational efficiencies of Kubernetes, or if you're out there in the full hybrid multi-cloud where you've got private on-prem, you've got public cloud, you've got a mix of hosted, you really want to have that single pane of glass. You want visibility across the entire fleet. Really being able to define as a desired state model how your fleet should look, what that configuration should be on one cluster to the next. So really giving you that control and that command. So we'll start with a good kind of look of what we're doing and from a product perspective, and try to answer your questions as to how we're doing that from an architectural point of view, how we're defining that, how we're implementing that desired state. So hopefully you guys have some questions that you're thinking around DevOps and GitOps and security ops and how we kind of define all that in a multi-cluster approach. We do kind of focus on 3 key lifecycle areas. We talk about the cluster. Of course, the lifecycle of the cluster is probably where most of our operations teams will begin. And we really want to try to ease that management pain so that you're not having to wake up on Saturdays and Sundays and do more work. The policy-driven compliance, so really we have this picture called governance, risk, and compliance, which helps us define not only the security of a cluster, but also think about the configuration of that cluster. So what kind of elements in terms of OAuth, resource limits, certificate expirations, IAM, role binding. So all of the things that really define your cluster. Think about day 2 operations, how you spend that time to really articulate what this cluster is for. Is it a dev or is it a prod? Is it a QA test? Is it an edge? Does it have certain requirements for banking and HIPAA? So really the point around policy is not just thinking of it from strictly a security perspective and regulatory, but also in a configuration standpoint. So how do you define the configuration of a cluster that is always going to be there on time, whether you've just imported it or just created it from Rackham? And then the third key area is our application lifecycle management. This is really how we start to have a discussion around deployables and workloads, how we define those in a consistent way, how they can come out of a Git repo and immediately be sprayed out to 100 clusters without you having to do anything special. Just by labeled assignment and a role policy, a placement rule, we've already determined how that workload should be distributed. So those are really the three key areas. We got the cluster, the security, and the application. And we'll talk through those, and hopefully you have some questions on your mind about how we tackled those lifecycle areas. The benefits, I'm going to just go ahead and say these are all in the box. I don't want to spend time. We're really trying to reduce the bottlenecks in terms of getting development to production. So how do we streamline central IT? Reduction of costs is a table stake. Increased application availability is another table stake. And then the ease of compliance. That's really a unique area to really bring that security role to the forefront and say, we're going to have a conversation with security, and we're going to make sure that development and operations are all at the table. So everybody's at the table at the same time, talking through what does security mean from building out that application all the way to the deployment to the clusters, to really bring security to the forefront in these conversations. A quick blurb about 4.5. We do run on OpenShift 4.5, so I know that this audience is very familiar with what's going on there. So just a quick level set. We run as an operator. We come out of Operator Hub, and we run on top of an OCP cluster. I just thought it was relevant to kind of lay the land. This is what's new on OCP 4.5. It's just a handful of improvements that are going on at the hub, the OpenShift layer. And then in terms of how we fit in, we are that purple bar across the top. We are the multi-cluster management tool that kind of has a full purview and a full look towards integration and control all the way down the stack. So across all of the OpenShift everywhere mantra, wherever you find an OpenShift, you can have OpenShift management. We can also manage non-OCP clusters. So Kubernetes as a target, we handle AKS, EKS, GKE, and IKS. So here's the big perspective with the purple bar across the top. Hopefully that helps you understand where we sit in the cake. And from that point, I think those are the only slides I wanted to blip through. There's a hub. We'll talk through about the hub today. It has a layer that's running on top of the OCP platform. I mentioned that. And then we have a managed cluster. And the managed cluster runs an agent, which is how we interact and have a secure format for being able to talk to those secure endpoints and make sure that they can come up to a desired state, which is the model that we use here with Rackham. So that's the 2-minute spiel. I think it took more like 10, but I think we're at a point where we've got the table set. I really hope that there's some questions that have already popped up, and so maybe Jimmy has a good chance to sprinkle some of those into this point of view, or maybe we should take some.
We have one question here that kind of came up around OBC ACM. So the first question is, what are the plans that we have with ACM for OKD? And they link to a blog where there's some talk about it. So they're basically asking, is this just a matter of time that we're integrating with OKD, or?
So OKD is the upstream, right? So we're talking about origin, the origin of all of this.
Mm-hmm.
It's the one that OKD4 just released, and about, I don't know, Wally could probably correct me, I think about 4 weeks ago.
Yeah.
And Jill, can you move that?
What's that? I heard you, Josh. Wasn't sure if that was for us. Diane, we're aware of that OKD release. I'm excited to say that I have seen.
The question though is really about when do we make Rackham available open source, right? There's a reference to a blog that we can drop in the various chat streams that talks about that pattern. So we deliver some of the operators today to the community operator hub. So you can deploy some of the parts of Rackham like Hive, which gives you some APIs around OpenShift cluster management, like our application subscription model, which is how we distribute applications across many clusters. We will have other community operators that feed into that over time. There's some work around cluster registration and a cluster agent based capability that's used in Rackham becoming a community operator as well. The GitHub project, Open Cluster Management, is where we are making these things publicly available and where we're engaging the community. There are some people who take the operator and try to run it in OKD today, and we will support importing an OKD cluster. We only provision the full OpenShift installer provisioned infrastructure patterns on the 3 public clouds, but you can import and manage an OKD cluster today. We do, from a support perspective, really target the Rackham hub running on top of OpenShift as its base hub cluster, but the technology itself, I think, would be runnable on OKD. It's just not something we prioritize documenting and driving the involvement, because we're looking for community involvement to help drive some of that. We're more than happy to help support the community and may end up doing more of that ourselves. But I think really the point there is, when are we open sourcing Rackham? And large parts of it are already there today around cluster lifecycle, around the application model, around the policy framework. There are some parts like search and the UI that we're working through the path to open source now.
That's great news, actually. And the OKD working group has been working through which of the operators are going to be available in the catalog that comes with OKD as well. So if people are interested in that, you can go to okd.io and find all of the operatorhub.io is for generic Kubernetes. So creating the operators that work with OKD 4, which runs on Fedora CoreOS, has a few more steps involved in it, just as creating other things. So there's a little bit of work that has to go on, but besides open sourcing your work, making it work in OKD 4, and that is along with the documentation on the OKD community to update and blog about. But we'll definitely reach out to you guys and invite you to that party.
Thanks, Dan. It's funny because on Friday, Michael, I was looking at the telemetry data and I saw an ACM hub running on it. So somebody out there is already doing the work for us. That's the community model, right? Yeah. Somebody's already taking a look at that.
Oh, that's cool. So I had a question for you guys. How does this, you talk about it in terms of DevOps in your presentation. How does this surface for developers? I get the DevOps stuff, and this feels to me like a very operation admin side of the house thing. But how do you see this adding value to the developer side of things?
So a few areas, really. I think one, how do we enable developers to get access to the right kinds of resources? How do we make it easier for them to actually create clusters or to deliver content to clusters? Rackham is not so much about creating a new application. You're not going to go to Rackham and scaffold a node app and convert that to a container image. You're going to use the dev tools from Red Hat around that capability, right? Use Odo, scaffold in a new application, use things like S2I, convert that into a container image, package it up with YAML. Where Rackham's going to step in to help the development and delivery process is really from the point that you've got assets in Git and an image registry, right? I've got assets that are ready to be deployed. And then Rackham defines a model of the application that lets you link those things that need to be deployed to the right location. I don't know if it's helpful. I can jump into kind of showing what that looks like in a real environment.
That would be awesome.
All right, let's take a look at that over here. So what we end up doing within Rackham, we have an ability to create clusters and import clusters. So as a developer, I think it's been our experience that developers probably touch many clusters less often than like a site reliability engineer, right? An SRE, site reliability engineer type of role, or an operator type of role, going to have more of this type of view. A developer might only see the 1 or 2 clusters, like their dev and QA clusters that they're working within. But when they start to think about the application model, in fact, maybe one quick application example is built off of WordPress. And this repo is public. If anyone wants to poke on it, we can drop the link in. But today we leverage the community SIG application kind to define the application itself. And then we've got some concepts that basically allow us to reference a GitHub repo. And so this application is going to be picking up the WordPress app from the Kubernetes customize examples. And from there, when we want to deploy it, we're using part of Rackham's dynamic placement engine to describe where we want this particular application to be deployed. And so this dynamic placement rule, so let me make my text bigger here so you can actually see what I'm trying to show you. In this model, we've got the application, we've got a link, the subscription, which is basically a reference back to the GitHub repo, in this case, the customized repo into the Kubernetes SIGs org. And then we've got a dynamic placement rule, which is matching clusters based on a label, right? So all clusters can be labeled. They have labels like the cloud that they're running on or the vendor. And then I can add labels like in this example, purpose equal development. And I can define the number of replicas that are desired as well. And then at that point, Rackham takes over to begin delivering the application to those target clusters. And once they're deployed, I can see, okay, where are the pods for this application running? So now as a developer, instead of having to switch my terminal between multiple Kubernetes contexts in order to see what's going on with the pod in this cluster, what's going on with the pod in that cluster, here I'm leveraging the ability in Rackham to index all of the things, and I can use search to actually drill in to the details or to the pod logs in this case. But what's also really neat is I can actually look at all of the objects related to the application in one query. So here I can see the deployment, I can see the cluster it's running on. If this were federated across many clusters, then I'd see the deployment for each cluster. If the application had more than one subscription, maybe it had a front-end subscription and a different back-end subscription that happened to be placed on different clusters, I'd get one unified view of that. So a lot of what we're after is to help developers make sense of it once you start getting into some of the QA staging and production environments where you're likely to actually run across many clusters.
That was an awesome overview. Thank you, Michael. Trying to see if, oh, there's a follow-up question. That one's directed to you, Scott. So when you say private on-prem, does that include restricted/disconnected clusters on-prem? And is Rackham targeting only IPI cluster, OpenShift clusters for now in the 4 public clouds, like Michael says?
Yeah,
so it might be a good time to clarify.
Great question from Waleed. So the on-prem, yes, we do support disconnected clusters. In fact, the hub can be disconnected as well as those managed clusters. And we're working through scenarios to ensure that we have a fantastic user experience with upgrading of those disconnected clusters. So we want everything to be seamless from the management plane that Rackham provides, whether that's a connected or disconnected environment that you're managing. And then what was the second part of that was around, IPI. Yeah, so Hive is the API that we're targeting, which handles the IPI installation flow. IPI is installer provisioned infrastructure. And so when, I think it's Michael that's driving, when he drives through that create flow, we're targeting that Hive API to handle all the infrastructure management that's underneath the cluster. So storage and VM and networking, that's all tied in together at the IPI layer. So if you have UPI, which is the user provision, we can import those clusters. So any existing clusters in your fleet or anything that you're carving out through UPI flow today, we can take and import that just by giving it a name and a label. You now have it under management. It can be targeted for security policy or application workload deployment. Just a few quick clicks and you get this import command that you would run in the kubectl of your target cluster or the OC command that you're running on the target cluster there. Yeah, so Waleed, for importing cluster, I see a follow-up question there in the chat. Your question is, can it be either another cluster type other than OpenShift? And the answer is yes. So we always have a red carpet experience with OpenShift. We know more about Red Hat's cluster. We know more about that ecosystem. That can mean we know more about operators. We know more about the underlying network capability and storage. We'll always have a more rich experience with an OpenShift cluster. We can also import Azure Kubernetes service, Amazon's EKS, Google's GKE, as well as IBM's IKS. So those are 4 managed service Kubernetes types that we can import and do management of. And when I say management, it means I can see it here in the inventory list, but I can also define labels and start to target those for management scenarios around application, as well as security policy. So in this case, I have a Eureka, which is a EKS cluster running on Amazon. Its purpose is development. So I'm doing some quick dev test on that cluster. Same thing here with my GKE. When it comes to my production workloads, I happen to be running, a Singapore and a Portland. These are defined more towards a production, and I can start to target workload differently depending on which channel it's coming out of. That's an area of expertise that Josh hopefully is itching to talk about, and hopefully we have a question that targets how are we able to deliver that content with some smarts that we know it's going out to a dev cluster or a production cluster, and in some way we have control over where we're funneling the workload out to. I hope that covered the questions there.
Yep, it seems like it did. He said, thank you. Excellent. So yeah, that's another good point, right? That to dive a little bit deeper now that we have the cluster screen there, and we can kind of see the different types of clusters too that we have available in the web, we have imported versus some of them we have built, right? And you can see the functionality also that allows us to do upgrades to OpenShift clusters, which is something that we didn't really talk about, right? That's
and Jimmy, that really is a key aspect here. As Scott alluded to, we're always going to have more capability for OpenShift for a number of reasons. In particular, we can drive upgrade of OpenShift clusters regardless of what infrastructure they're running on. So we can trigger an upgrade, pick an available version, and target it if that cluster is running on a cloud provider. Like here, I've got Azure or Amazon, or in this other hub, I've got some in Google as well. But if that were bare metal, if that were OpenShift on VMware, we can still drive the same upgrade behavior. And a lot of that has to do with the very operator-centric nature of the way that the OpenShift cluster is configured and how it's operated and how it's maintained. We're able to trigger the cluster to go in and drive a more intelligent upgrade path than we could for an assembled cloud provider's version of Kubernetes. What's really powerful when you start thinking about all of that API surface area to configure how OpenShift runs, like how I do identity providers, how I define authentication, how I manage the network configuration of that cluster, how I manage the storage configuration of that cluster. If I want to augment it with security behavior, I can drive all of that through the operator catalog, and I can use Rackham to actually deliver content through a set of policy behavior down into those OpenShift clusters. So in this case, if I want to configure the identity provider for my cluster, I can define a policy, I can define a label, in this case, authentication profile, and it's got a list of available values. And then it's matched certain clusters that I have under management that have this appropriate label. And what this particular policy does is it requires that an OAuth API kind be configured on that remote cluster, along with a default HT password configuration secret, and that drives the HT password identity provider. And now if I go log into some of these managed clusters, I'll be able to take advantage of that. So whether I create the cluster or import the cluster, it's always driving that down, and it's using that operator surface area to do that type of change. That's also true for image manifest vulnerabilities. Here we've got an example that is pushing down a subscription to the container security operator. And so in this target cluster, it has deployed the container security operator, but there's still a violation because it's actually finding an image manifest vulnerability record, which is basically an API kind that records that one of the containers in that cluster has a CVE, right? Has a common vulnerability and exposure that needs to be remediated. And I could only do that by going and updating the version of the container image that's backing that pod. So here I'm able to enforce the behavior of having the operator deployed and then also validate this additional concern that it must not have any of these records and indicate there's a problem. So those are operator-based policies that really only apply in terms of OpenShift. If I'm just doing things like namespaces or roles, so here I might have a policy that I wanted to create a particular namespace called prod apps on my target cluster and a particular limit range on that namespace as well. This policy will work on the EKS clusters, the GKE clusters, AKS, IKS, because they're just base Kubernetes API. But really, to take advantage of that powerful operator ecosystem, that's where we focus more on OpenShift and try to simplify that, the nature of that open hybrid platform working the same way consistently everywhere.
So we had a question come up around RBAC and how do we handle RBAC from an ACM perspective? I think that's a good one to kind of go over. So I don't know, Scott, Michael, who wants to take it?
Yeah, I feel like I've talked a lot, but I'm happy to take this one unless someone else wants to jump in. Okay.
So you got it.
The smooth delivery. I'm almost taking a nap here. Keep it up.
All right, so I don't know if I'll be able to pull up the page fast enough, but if you look at the RBAC documentation for Rackham, we define a number of roles. In fact, now this is going to be an opportunity to show off one of my favorite Rackham features. So Jeff and Scott are going to chuckle in the background at me. So what I'm going to do is I've opened up our visual web terminal. This is just it's a way to interact with the same type of terminal commands that you normally run, but formatted in a nicer way, right? Formatted more like a web console. And what I'm going to do is show you the cluster roles. And here I'm actually running on my hub cluster. So let's look at all the cluster roles that are on my hub. And you'll notice I've got all kinds of things. But if I scroll up here, you'll see a whole wave of cluster roles that start with this open cluster management prefix. And one of these is the open cluster management :cluster manager admin. Now, if this were just a blank terminal, I'd have to go and run a get o YAML command in order to show you the detail. But Visual Web Terminal, I can just pop it up and get that detail here. So this particular cluster role gives a user access to do all the things with a cluster: create clusters, import clusters, etc. Now, if I want to assign a user to a particular cluster, whenever we create or import a cluster, we actually create a role called open cluster management :manage cluster name of the cluster. You may notice Golf, India, Hotel, Juliet Alpha. These are clusters that are registered on this hub. And this cluster role is dynamically created. And if I create a cluster role binding to my user, now that user will be able to view that cluster. If I logged in as a user that wasn't a cluster manager admin, wasn't a cluster admin, was simply, maybe I added a role for Scott, and I could create a cluster role binding for Scott to the India and the hotel cluster roles that you see here. And now Scott would be able to view only India and only hotel. He'd have full control over those clusters, but he wouldn't have access or visibility to the rest of the clusters as well. I would also assign Scott, behind the scenes, we also are creating a project for each of our clusters that we create. And the project serves as a home to basically hold the policy resources or the application resources or other authorization resources like additional service accounts and things like that that interact with that remote cluster. And so I'll also see Juliet Alpha, India Hotel, etc. These projects are defined as the cluster is created or imported. So I would assign Scott a binding to that cluster role that gives him access to the manage cluster API object. and then I'd assign him access to the hotel cluster. And then from here, if I look in, I think hotel has some, but we'll see how many policies. So these are the policies that were dynamically matched based on a placement rule for the hotel cluster, and were delivered into this particular project, into the hotel project. So Scott would be able to interact with the managed cluster API object, view and list the details on it, see its help, but he'd also be able to look at and modify content here in the namespace, which would let him define a placement rule and deliver content to hotel or to India, but no other clusters because he didn't have access to those other clusters.
And let's be honest, Michael wouldn't give me access to anything unless he really wanted me to break it. So that's a very good hypothetical scenario. And I appreciate
I don't know if other teams use product managers for chaos testing, but it has worked well for us on the Rackham product engineering team. So,
we are the best. We are the best. So there's that aspect, Michael, but there's also our ability to use policies to configure IAM, right? And there's the roles and beginnings on a managed to scenario as well.
Absolutely. So maybe let's talk about that. So here, I'm just going to pull up the policy that was in the hotel namespace that came up here a moment ago. This is a policy which delivered to the hotel cluster, and it is defining a auditor role config policy. Actually, is it auditing or defining? Let me just double check. This is only auditing. So policies can either enforce, meaning that they create the thing that's under management, or they can simply audit. Has it been modified from what I expect? You might use audited policies as you're building up the library and you want to ensure that it's doing the right thing before you enforce it. But if I wanted to automatically create a particular role or particular role binding, then I could switch that flag from remediation action inform to remediation action enforce. And then I could define a policy that had a number of things. So for my Scott user example, I can create a policy that assigns Scott perhaps the edit role in a number of projects, and then the role binding content for that I'd put in the same policy. I'd actually, here I've got an example with a role and role binding separated out. I would probably lump those together. And then in addition to defining, defining the user, which I could do through the identity provider policy, I would have defined the role or the cluster role, define the role binding or cluster role binding, and maybe have another policy that defines the project along with configuration like network policy and limit ranges. And all of that would be bundled up and give me a way to onboard Scott with a very specific configuration to a target cluster. And then even if Scott didn't have access to log into the hub, if he didn't have any of the other cluster role bindings we talked about a minute ago, he could log into the target cluster and he could view all the resources that were there.
Yeah. And the cool part, just to add on, and Michael, thank you. This is a desired state model. So what you've defined in terms of this profile for my cluster, it's going to work towards that eventual state, but you don't have to go in and add anything else, right? You've already defined like the profile of what that cluster should look like and feel like and what it can do. And another cluster that comes onboarded, or another 10 or 15, isn't going to make you hemorrhage on a Friday afternoon to go configure stuff. Those are just going to be imported, work their way up to that same policy configuration that you've defined, so that another team is now ready, and their clusters are now ready for them to do work.
That's a critical point, right? This dynamic placement engine allows us to create placement rules that are very declarative, that again match by label. If regardless of when the cluster is created or imported, as soon as the labels are applied, the dynamic placement engine will match them and then roll out those changes. If we want, we can look at that example for the container security operator. That's helpful.
I think it'd be cool to see some application or workload that we can fire off in a different direction, with a placement rule.
Well, let's do this. Let me pick on image manifest vulnerability.
Cool.
And in this case, I think it's only applied to one cluster, golf. What I'm going to do is bring my clusters page up again. And since we're playing with the hotel cluster, I'll launch out to its console. And let me see what operators it has installed. Perfect. So the hotel cluster. So I launched the console for hotel. I don't have any operators other than the default package server here. So what I'm going to do is edit a label. And I'm going to edit a label. I'm sorry for jumping around. Give me just a moment here to get to a point where I can show you what I want to show you. And I'm going to try to catch it in the act of doing the work. So over here on the right, I've got my target cluster.
It looks like we're not seeing that new window of hotel. We're just only seeing the Rackham
Thank you
tabs.
for jumping out on that. Let's just share this screen. Okay. How about now?
Yeah, you can. Overlay. Perfect. Thanks.
Awesome. So I'm going to go add a label to golf, or excuse me, to hotel. And as soon as I add this label, click add and click done. And I'm going to try and get over here fast enough. A detected hotel is not compliant. Within a few moments, you'll actually see the installed container security operator populate in. So you can see it is going through and triggering the installation of the container security operator on the hotel cluster. And then once it completes that aspect, the policy is twofold. It is both requires the operator to be deployed and requires that there not be any of these image manifest vulnerability types. And so the policy has a must-have, but also, and let me scroll down here to the bottom. This is a longer one, but it also has this compliance type must not have, right? So it must not have an instance of this API kind. And if it finds that, then what it knows is that the container security operator found a vulnerability. In the cluster, this will get surfaced up on the overview page. So in fact, if I come back to the overview, I can see there's one image manifest vulnerability. And in fact, now I'll see the second violation is already up. So within 35, 40 seconds, whatever window that was, I simply updated a label on a cluster, had the policy trigger, had it modify the cluster to bring it in to alignment, but then it figured out there's actually still a remaining issue that needs to go and be remediated against that target cluster.
That's right.
Absolute magic.
Magic. Well, we like to call it a desired state model for dynamically applying policies to a fleet of clusters.
That was awesome. Thank you, Michael, for showing that. So we have another question around being able to manage Kubernetes like Rancher, for example. And they also would like to know about support for like things like vSphere, UPI installed with static IPs. So I guess we can start with the Rancher question and then go into
I'll
vSphere.
try that one, Jimmy. I'll see. So, Rancher presents an interesting case. Literally, if you just bucket Rancher as a non-OCP and you're talking about Rancher Kubernetes engine, by virtue of the fact that those are standard Kubernetes APIs, we could probably talk to it. We could probably manage it. Now, I don't really care to do that because there's 64 Kubernetes that are CNCF certified out there in this world. It's not really incumbent on me to invest in that direction. All right. If I have a lot of people that are clamoring for that, maybe we'll go in that direction. We've chosen four. We've chosen four big dogs. Now, if I want to go down that list and pick a bunch more, we can do that. And I think what some people are finding is that our agent is going to work on those types. Does that mean it's under enterprise support of Red Hat? No. We haven't spent the time and the investment to do quality assurance testing to make sure our QE team has the time to vet it. Because I don't want to put that in front of an enterprise if it's not fully baked. So maybe there's some stuff going on in the upstream, Jimmy, and maybe there's some ways that folks are using that makes sense. We'd love to hear about that from a product management perspective. But we really want hybrid, open technology to meet the needs of the enterprise. Yeah, and I really want that to be a statement that brings home.
Yeah, Scott, I think it's 103. I counted the other day.
Okay,
Kubernetes certified.
It doubled over the weekend, and that's the point.
Yeah, so it depends on how you look at it. Some of them are the hosted ones, and some of them are the installers and stuff. But if you go to the CNCF landscape right now, there were over 103 at the last count. So and it really is very much a community effort to do some of those testing on those. And yeah, so that's a community.
Thanks for the update. I was not intending to spread fake news.
Yeah,
Keep me on my toes.
it's
Thank you.
bad.
So
Awesome.
maybe I could take the vSphere one or the
Yeah.
UPI question. So pretty much where we stand right now is, and this touches a little bit on the question above it that was asked to Scott about a roadmap, is we have the VMware IPI, which we touched on, which is coming in the fall release. If you have UPI deploys though, so user provisioned installs of the OpenShift, you definitely can import them. And Michael had shown previously sort of the steps to that. It's pretty much you give it a name in OpenShift and it gives you back a big long command. And as long as you're logged into that OpenShift, you can cut and paste it and it'll import. And I guess one of the pieces we didn't mention, and maybe Michael, if you can bring that, the cluster list page up, just because you had a number of clusters to upgrade, whereas I think my demo only had one. There were two things I wanted to touch on here. One is once you imported it, you'd obviously be able to upgrade it. So we don't have to provision the OpenShift to be able to upgrade the OpenShift. As long as we're managing it, the upgrade becomes available. And the other piece we didn't touch on was you can do bulk upgrade from the console as well, which is another key point. So you have a number of these, you can select them. You see that the upgrade on the upper bar comes available. And as you click into that, you'll get a list and you can choose specific versions. So you don't even have to push everybody to the same version if you don't want to, or if you have a mixture of 4.4 and 4.5, you'll be able to pick from the list there as well. Hopefully that answers the question.
Yeah, that's a good point, Josh. Your team's been working hard on delivering the vSphere IPI tile. So from the add cluster viewpoint, when they create a cluster, we're going to continue, Michael, if you drive in the create cluster, the icons that are in the create flow are going to continue to grow. So today you're seeing 3 public clouds up there. We actually do support the bare metal in tech preview, not available on this environment, but it's available in tech preview right now. vSphere is coming in the fall, and we're going to look to add additional infrastructure providers down the road. Anywhere OpenShift is available today, we're looking to target that same OpenShift everywhere mantra.
Awesome. Yeah, and I think this is a perfect kind of getaway to go into and talk a little bit about applications and application deployment within clusters. So we touched a little bit about creating clusters. We talked about securing your clusters, right? And being able to have that policy and governance. And then maybe Josh, you mind kind of showing us a little bit the application world?
Absolutely. So hopefully you guys see my screen and you see the different channels and
Yes.
not my other page. So in the application space, our application system is pretty much the continuous delivery portion that you would find in CI/CD. And so just to roughly touch on these before we take a look at a system, you've got GitHub types, so you can have your deployment service definitions or customization YAML, so the customize feature defined in a Git repository, and you can have an application have a subscription for one or more of these repos and or directories within it. We also support Helm releases, so you can subscribe to a Helm repository and pull in a Helm release based on versions or a parameterized version of it, so like greater than version 2.0, or I want to keep my production, less than 2.0. And greater than 1.0. We have object storage as well, which can be third-party provider or a Minio running on your OpenShift cluster. And then as well as sometimes the term deployable comes up, but it's pretty much Kubernetes resource template. So I can create a template for a deployment resource or config map that I want to transport to all of my managed clusters. And so this is a very simplified version or flow, I should say, for how this works. And so you've got the hub here on the left, and that is where you define the initial subscription. And then using the placement that Michael mentioned before, it defines a set of targets. And so the matching there's actually a number of different capabilities. Let me just bring it up here for a second. Yes. So here there's a couple of different ones. So there's conditional types. So this condition is an example of I want placement to only match to systems when they're online. This is usually the default that folks use, but there can be a circumstance where you want it to at least attempt to apply, even if the system isn't online, so you can see that there's a failure and your app isn't in a location that maybe it should be. We keep talking about the labels, which is the most powerful because of the fact that any system I deploy that comes up with that label will match the placement rule and therefore get the app or the policy. We share the same placement rule technology in both. And then we have the more traditional cluster list in that you can specifically list a arrayed list of cluster names that you want the system to deploy the app to. This also works under policy. And whatever is defined in that list are the only ones that are going to find this application on them. And so when we look here, the flow is you define the subscription here on the left. It flows down to the managed clusters. The subscription running on the hub then queries the Git or the Helm repo or the object store to pull in some data so that it's able to display a topology for you. And then these propagated subscriptions pull the data directly from Git or the Helm repo or the object store and apply it on the system. And so when you do that, over to, they're both here, one of my systems, you end up with an application object that's listed at the top. And so here we're doing some NGINX pieces. You can click into that, and what you get is this topology that we saw before. So hopefully it's not too small. But as Michael had pointed out before, you have that application object that ties together all the pieces that make up the application that you're going to be using. In our case, we have two different subscriptions. One is for the ingress. You see ingress NGINX here, and one is actually pushing the deployment. You can see by the connectivity here, they're both connected to the same rule. So they're both using the same placement rules, so they'll end up in the same spot. And then we have the actual cluster. In this case, it's targeted to just a single cluster, and the deployment and the replica set that comes with it, as well as a service object. And so this type is a Git subscription. And so we have here a little bit of information about it. When you click on the properties, you can view the actual YAML and get the search outputs that we saw before. But here we see it's pointing to the GitOps demo piece, as well as some of the information about it. So maybe what we'll do is show this a little more in action. There was another question that that's come up. Jimmy, were there any other questions? When I shared the screen, I lost my chat list. So
no, you're good. You're good.
All
keep
right,
going.
we'll keep rolling then. Difficult to navigate to these, but so what we're going to do is I'm going to take advantage of the fact that this is my cluster here. So I'm on the cluster page. I want to go to that cluster so I can show you guys what's going on as this happens. So I was in the cluster info. I clicked the link to get to my cluster console. So this is my remote JNP system that's deployed in AWS. And I'm going to go to workloads. I want to take a look here. I see I'm in the NGINX Blue, which is the same NGINX Blue that I was looking at over here. I see a number of my apps. So this app has a subscription that points to a channel, and that channel is in GitOps. And so here we see NGINX, it's 12.12 that's deployed. And when we go back to the system, if we take one of these pods and we look at the events, we can see the image here is 12.12 that's deployed. So we're going to go back and watch the pods. So we're going to make a change here. Edit. We're going to switch it out to the 14.4. And so one of the key things to keep in mind here is that when you're using GitOps, you can make a change here. I can commit it possibly to my branch, but with branch control, I may not be able to commit to the specific branch that the subscription is watching. So you can have approvals required to merge it in first, etc. And then in this case, we're doing this is part of a blue-green type of demo. So I just made a modification to the blue. So I changed it to 1.142. We can see here, we've already got the pods terminating, the new pods coming up. So if we click on one of these new pods and we look at the event, we'll see now we've got the 1.14.2 that we were looking for. And so that's the first, so that's the Git ops being pulled down. So ever so often, there's two ways it works. The subscription either does a polling monitor of the Git, depending on what your firewalls are, or you can have a webhook push, which when there's a change in Git, it's going to signal to the subscription that there's a change, and it will happen pretty close to instantaneously to when you do the commit. And so the next piece you can do is we go out, we test, we make sure everything is going well here, and then we can go to pull requests, and you can actually do true Git ops. And so we can go from our blue to our green, and we can create the pull request. And you can see the file change. So this is the versioning change. And then when you push this, it will go out and we do the merge. All of the green systems that are watching it are going to take advantage of the change too and get those pushed out. You'd see a quick flip here. It's hard to detect because of the search polling, but the versioning does change over. But we can do the same thing on the system here and switch from blue to the green. Give it a minute, let it flow through. Maybe what we'll do is we can come back to it in a sec. All right. Questions? Anything else, Jimmy?
None coming up right now. So I figure with the last, that was great overview. Thank you, by the way.
And we see it's
so
changing over here. So
yeah,
that's
excellent.
Yep.
Excellent.
Excellent. So hopefully that gives an idea of how applications kind of work within ACM. So I think with 5 minutes left, I kind of wanted to talk a little bit, put you on the spot, Jeff. So I kind of wanted to see if we could talk a little bit about ACM and how is ACM going to be integrating into the broader Red Hat portfolio? Obviously, being that this tool came from IBM, right? We can establish some time to kind of build it into the Red Hat system. But going forward, what are we looking into from a portfolio integration?
That's a great question, Jimmy, and I really appreciate the time and the from everyone on the panel, including our guests today. But we're really excited, as Scott probably let us with, is that the GA was at the end of July. We'll have our new release coming out later on in this fall winter time frame. We typically stay on a quarterly release cycle, so you'll expect that to come in around the 3-month period. But from a portfolio integration perspective, we have a lot of things going on. When you think of ACM, there's primarily 3 different pillars of functionality that we focus on, and a fourth that surrounds them all in observability. But we saw a lot of demonstration on cluster lifecycle, policy governance management, as well as Josh just rounded out the application lifecycle. And in each one of those areas, there was opportunities for our integration. We already see that our tight integration with the Hive open source community and cluster lifecycle. In the policy and governance area, we're working with the compliance operator team, bringing in some of their work as well. We have a lot of opportunities to work with insights and telemetry and pulling in that part of the portfolio here in the upcoming months here. But one things that we're really excited on is that, as you know, we have a world-class Kubernetes platform with OpenShift, and we have the de facto standard in automation with Ansible integration automation platform. And bringing those two together in context of those 3 different use cases is something that we're really excited about from a cluster lifecycle perspective, application lifecycle perspective, and from a policy risk and governance perspective. We're going to start off looking at some of the things in application lifecycle, as Josh just showed you, deploying applications at scale. What we hear from our customers is, I want these clusters to be stood up the same way, and I want to be able to upgrade them easily. I want them to have the same configuration in a lot of cases, and I want the same applications deployed. But there's a broader world out there besides outside the Kubernetes domain, and that's where Ansible automation platform comes in. When we think of ACM, we really focus from the concrete to the heavens in terms of Kubernetes management and being able to do automation and enforcement. Ansible bringing that into the mix, working better with OCP. Now, if you can imagine a scenario where Josh just demonstrated an application is being deployed to new clusters, there's a load balancer that needs to be updated. There's information that needs to be updated in CMDB. So we're really opening up these hooks. I'll call them hooks in each one of these life cycles, so that customers can really integrate any of the collections or the workflows or anything else that you want to invoke from an Ansible automation platform perspective. And that's really the art of the possible. We have obviously some key use cases that we work with our customers and have kind of honed in. And like I said, the application example, I've deployed an application. Now I need to, update the firewall or update CMDB, or I need to maybe adjust some things on the external storage front. From a policy and remediation perspective, you can imagine collecting logs, doing quarantining activities, and other things like that are our key use cases there. And in cluster lifecycle, when we get to that, opening up those hooks, pre-provisioning a cluster, allocating storage, post-provisioning cluster, updating CMDB, updating load balancers, making those available to the scale of developers that are out there, are some of the use cases that we're thinking about in the immediate term for integration with Ansible Automation Platform. And so we'll see some things coming up in the Ansible Fest. We'll be talking about that and doing demonstrations, and then we'll progress down the road. So if you have a customer is really interested in that type of integration, then please reach out to anyone on this panel, and we can start to work through those use cases and make sure that they're going to be addressed when we come to market. I think I ran us.
Awesome. Yeah, that's great. Thank you so much. Appreciate that, Jeff. All right, and then with that, I guess, Diana, let you close it up.
I would love to. Do you have in your slide deck, though, Scott, maybe one final slide with any resource links and that you can share to end this with, so that people can find you? And then everything that you've put in the chat here, all these wonderful links to all the different Red Hat documentation sites, we'll incorporate that and repost that with the slides up to the YouTube channel in the next day or so. And it would be great if you could put it on their speaker deck. And we also link them to on the events calendar for OpenShift Commons. So yeah, that's we'll expand those URLs that are linked in there as well. So yeah, and we'll get that out to everybody. Yeah. The new virtual world is kind of like, sometimes you feel like it should be clickable and sometimes it's just not. So like I feel like I should be able to touch my screen and click on anything that I see, but it's not quite there yet. So we'll make it happen. And really, guys, thank you very, very much for fielding all of this, all the questions today, for coming and giving this talk. I think it was really timely. And tomorrow is the OKD working group meeting, so I'm sure Waleed will be on there picking our brains about how to get this going, because he seems to have to demo it for an AWS meetup soon. So there's going to be a lot of collaboration going on, and it really is nice to see this and to see the open source side of it and all the work you guys are doing. So again, thank you very much for coming. Totally appreciate it, and we'll look forward to seeing some stuff at Ansible Fest coming up soon, and making sure that, I think Ansible Fest is in October. Is that right, Jeff?
Middle of October, that's correct, yeah.
Yeah, so there'll definitely be lots of opportunities to check this out with the new releases and everything. So we'll have you back soon. Thanks again, guys.
Thank you.
Thanks, everyone.
Thank you.
Thank you.
Thank you so much, Diane. You guys be safe.